Hello, my dear students and the rest of the learners. Welcome to part 33 of a 7-part series of tutorials in computer structured programming in C and Pascal. This is section 12 of 13 in the topic data structures. My name is MemGM, but you can simply call me EMELISWAP. In this tutorial, I'm going to look at the data structure that we call queues. We are going to look at the introduction to queues, the operations that are performed in queues. Then we shall look at the implementation of queues and the application of queues. What are queues? A queue is a dynamic data structure into which data is entered from one side and removed from the other. The elements are added and removed using the first in, first out principle. The queue operations are those activities which are carried out in queues. Generally, a queue is a homogeneous collection of elements in which new elements are added at one end called the rear end, and the existing elements are deleted from the other end, which we call the front end. The elements to be inserted into the queue possesses their own priority. So, queue nodes are removed only from the head, that is from the front of the queue, and are inserted only at the tail, or what we call the rear of the queue. An example of a queue is a priority queue that is used in applications such as job scheduling within the operating systems. A priority queue is composed of several independent queues, each having a certain priority associated with it. The priority of an element decides which queue it should enter into. When an element is enqueued, it is inserted into the queue of the corresponding priority level. When an element is to be dequeued, the element from the highest priority queue is removed first. If the elements of the lower priority levels have to be removed, then the queues of higher priorities should be emptied. The insert and remove operations are known as enqueue and dequeue. Enqueue is the process of adding a data item to the queue. The operation of deleting a data element from the queue, however, is known as dequeue. So enqueue is the process of adding a data item to the queue, while dequeue is the process of deleting or removing an element from the queue. The first element in a queue is said to be at the head of the queue, while the last element is said to be at the rear end. So, an element is enqueued by being added to the rear or the tail, while an element is dequeued by being removed from the front or head of the queue. If the queue is empty and an attempt is made to dequeue an element from it, queue underflow occurs. In addition, if an attempt is made to enqueue an element into a full queue, then a queue overflow occurs. The major operations that can be performed on a queue are the enqueue, then dequeue, and the traversal. The following are the algorithms for enqueuing and dequeuing. To enqueue, number one, or first, initialize the front with -1 and the rear with -1. If the rear is greater than or equal to maximum size, print the queue overflow and return. Otherwise, set the rear to rear +1. In other words, increment rear with 1. And then you can queue, that is the rear, by assigning to it an item. So assign an item to the rear of the queue. If the front is equals to -1, then you increment front with 1. What about to dequeue? If the front is less than 0, then print the queue empty and return, because it means there's nothing there. Otherwise, assign an item into the queue. So else item equals to queue front. So increment the front with 1. So front equals to front plus 1. So whenever we insert an element in the queue, the value of the rear is incremented by 1. That is, rear equals to rear plus 1. In other words, add the current content of rear to 1, or add 1 to the current content of rear and assign it to rear. And whenever we delete an element from the queue, we always increment the front by 1. That is, front equals to front plus 1. How do we implement queues? Queues are implemented either statically or dynamically as follows. 1, statically. This is performed with the use of arrays. Dynamically, by use of pointers. The queues that are implemented dynamically are called linked queues. The main disadvantage of implementing queues using pointers is that a node in a linked representation occupies more memory space than a corresponding element in the array representation, since there are at least 2 fields in each node, one for the data field and the other to store the address of the next node, whereas in static memory allocation, only data field is available. The following diagrams illustrates queue implementation. So the first one is array implementation. Here is our array, with one of our elements being the front or -1, while the last one is the rear. Remember, we have said that the first and the last elements are indicated with a unique element, which I've said it is -1. So we can be able to dequeue from the front, while we can be able to enqueue from the back. When it comes to pointer implementation, we do it as follows. So we can be able to dequeue from the front, and we can be able to dequeue or to enqueue. We can be able to enqueue from the rear. We can be able to enqueue from the rear. Initially, the front and the rear pointers contain null links before elements are inserted. So, in the implementation of a queue using pointers, the front and the rear nodes contain 2 pointers marking the first and the last elements of the queue. When an element is inserted, a new node is created, and the node is attached to the tail of the queue, and the new node is marked as the rear node. When an element is deleted from the queue, the front pointer is advanced to its successor. The deleted node is returned to the pool of available memory using the dispose procedure. However, a linked representation makes an effective utilization of memory. The problem with the static representation is that a space created by removing an element cannot be inserted a new element, and if you try to do so, the program generates the message that queue is full, though it is empty. The other advantage of linked representation is that an element can be added or deleted in the middle of a group of other elements. So what are the applications of queues? The following are some of the applications of queues, which include round-robin technique for process scheduling is implemented using queues. All types of customer service center software are designed using queue to store customers' information. Printer server routines are designed using queues. So a number of users share a printer server that is pulls all the jobs from all the users to the server's hard disk in queues. From here, jobs are printed one by one according to their number in a queue. And with that, my dear students and the rest of the learners, we have come to the end of section 12 in this series of topics, or in this series of presentations in the topic in data structure. You can now continue to section 13 of 13, or to the last section on data data structure, which is the last section of this topic on data structures, and that is section 13 of 13 in this topic. Congratulations for learning sections 12 of 13 in the topic data structures. You can also access sections 1 to 13 of this topic, other topics in the computer structure and the programming unit, as well as other computer or ICT videos by clicking or tapping on EMELISWAP ICT YouTube channel below this video. You can also visit EMELISWAP Life Skills YouTube channel for free life skills, motivational and inspirational resources. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emeliswap@gmail.com. Thank you very much for listening to me. Let's meet in the next part of this series. God bless.